Assalamualaikum and hi everyone. I'm Dr. Shazira, and in this video we are going to be discussing the Gauss elimination method with partial pivoting. Okay, consider this following system, okay, where we have three equations and with three unknowns, and we want to solve this system here using the Gauss elimination with partial pivoting. Okay, so first of all, extract all the coefficients of your unknowns, okay, and write down in terms of augmented matrix. You can have this kind of table, or you can use the common way of writing the matrix, okay, using the brackets and so on. Okay, so in the Gauss elimination with partial pivoting, so first of all, we need to make sure that at this position, which we call as a pivot, okay, so that location must be put with the element that is largest in terms of absolute value. Okay, so how to do that? How to determine the pivot element? So basically, you are comparing with the rest of the elements in the same column. Okay, so you are comparing between 0.143, negative 1.31, 11.2 in terms of absolute value. Okay, so you take the absolute value of those three and identify which one is the largest. All right, so the keyword is the largest in terms of absolute value. Okay, so we can clearly see that the largest element is 11.2. It means that 11.2 need to be put in the first row as the pivot. So to do that, it means that the operation that we need to do is R1 switch. So this is the notation for the interchange, okay, or switch. R1 need to be switched with a R3 so that, okay, 11.2 is now the pivot. Okay, but we cannot change only one element. So it means that the rest of the elements in row number 3 need to be swapped with the elements in the row number 1. So it means that we are going to have these elements to be at the top as well as the B at the right hand side. Okay, row number 2 is okay. Okay, you can remain as it is. Now, row number 1 will be row number 3 now. Alright, so we are okay now. That is the first task that you need to make sure, okay, in the partial pivoting. Otherwise, it is just the normal Gauss elimination, okay? So after that, once we are okay with the pivot, then we can proceed with the normal Gauss elimination procedure, which is, to identify or to determine what is the correct operation, okay, to make sure that this guy is 0. Okay, so similar to what you have before in the Gauss elimination, okay, so negative 1.381 need to be 0. So in order to do that, then the operation is R2. Okay, so put R2 at the left because negative 1.31 is at the row number 2. So put at the left, and then you put positive R2 at the right, and then you are relating with R1, row number 1. So the coefficient of R1 comes from, okay, remember last time we have done this. So the coefficient of R1 comes from the element that we wish to be 0, that is negative 1.31, over the element that we are relating to, which is R1 here. So that is 11.2. So put at the denominator. Okay. Now, think of this coefficient here, whether this is correct sign, okay, whether negative here is correct or should we put positive coefficient. Okay, so check with the R1 here. So R1 is positive and R2 is negative. Okay, so since you have the negative value here, okay, negative sign here, so when you multiply with the R1, okay, which is positive, okay, so you will have negative here, and then you plus with the, R2 is negative, so you will not get 0, okay, unless this part here is positive. Okay, so it means that instead of negative, so we have something like that actually. Okay, negative should be in front. Okay, so or we can simplify that coefficient should be positive. Positive 1.31 over 11.2 times R1 plus R2. Okay, so with that operation, we'll have this new matrix here. Just copy the first row because that one is already okay. But for the row number 2, so the first element at row number 2 should be 0. Okay, because of that operation. And then similarly for the rest of the elements in the row number 2, you must apply this operation here. Okay, so it means for this guy here, for 0.911, you need to do, okay, a 1.31 over 11.2 multiply here. So you will replace R1 here with the negative 4.3 and then plus with the 0.911. Okay, so the correct element, the correct value for the second row, for the second element should be 0.4081. Okay, so similarly for 1.99, so for this element here, so apply this operation to 1.99, so you should have 1.9192 up to 4 decimal, and the B element at the right hand side somehow is negative 4.9416. Okay, so I hope you can get on your own, okay, the value over that. Okay, so we are okay with that second row. Now think of this guy. So what is the operation, okay, to convert 0.143 to be 0? Okay, so 0.143 is at row number 3, so we put R3 at the left and we put positive R3 at the right, and we are relating with R1, okay, because R1 is already okay. And think of the coefficient. Okay, so the coefficient again comes from the element that we wish to be 0, which is 0.143, over the element that we are relating to, which is 11.2. And think of whether we should have negative or positive here. Okay, so basically you must look at the R3, which is the element that you wish to be 0. So since the element here is positive, so of course we need to make sure the coefficient here is negative. All right. So with that operation, we perform on 0.143. So of course we'll get 0. And then we also perform the operation here to the 0.357. So you are supposed to get 0.4119, and this is 2.0177, and this is negative 5.2294. Okay, so perform the operation for each of the elements in the row number 3. Okay, now we are settled on column 1 here. Okay, so we have these two elements already 0. Okay, now proceed. Okay, so the next aim is to make sure this guy here is 0. Okay, so you are now switching to the column. Okay, switching to the second column. This is where you need to think of the pivot one more time. Okay, so I can put remark here. So you are so this is basically your first stage, and this is your second stage, where you want to consider the second column now. So every time you switch to the new column, okay, you need to think of the pivot. Okay, so the pivot in the second stage is at this location. Okay, so now you, in order to determine which one is the correct pivot element, so you need to compare 0.4081 with the 0.4119 in terms of absolute value. Okay, you don't care about the element at the top here. Okay, you don't care about negative 4.3. You are not comparing with that. You only compare, okay, with the element underneath the pivot. Okay, so these two only. So in terms of absolute value, you can see 0.4119 is larger compared to the 0.4081. So it means that we need to swap. Okay, we need to swap between 0.4119 and 0.4081. Okay, so the operation that do that is basically R2 switch with a R3. Okay, so the rest of the elements in the row 2 as well as in the row 3 are affected. Okay, so it means that we will have okay, just copy the first row because the first row didn't involve with the process. That is already okay. So now row number 3 becomes row number 2. So 0, 0.4119. Okay. Negative 5.2294. And then we have 0, 0.4081, 1.9192, and negative 4.9416. Okay, and then we proceed with the normal operation in the normal Gauss elimination. Okay, so remember the keyword of the pivot, it should be compared in terms of absolute value. Okay, but when it comes to writing the actual element of the pivot, you write down the actual sign. If it is negative, then you put back the negative. Okay, you do the absolute value. Okay, you take the absolute value just to identify which element should be the pivot. Okay, but when it comes to writing, you write down the actual sign of that element. Okay, okay, now back to the aim to have this guy is 0. Okay, so 0.4081 is at row number 3. So we put R3 at the left equals, okay, so somewhere here is positive R3 at the right. Now you are now relating with row number 2. Okay, relating with R2. And the coefficient of R2 comes from the element that we wish to be 0. Is 0.4081 over the element that we are relating to, which is at row number 2, that is 0.4119. Okay, and think whether we should have positive or negative. Okay, since the element that we wish to be 0 is positive, so the coefficient here should be somehow negative. Okay, so now you need to perform the operation on this guy, and that guy. Okay, so what do we have? Okay, this guy here should be 0. Okay, because this one here, when you transform, Okay, using this operation, R2 is 0. Okay, so everything will be 0 here. Plus with R3, R3 is also 0. So you have 0 here. And 0.4081, so of course this part will be 0. And then 1.9, okay, 9192. So you perform this operation. So somehow you will get negative 0.0799. And lastly, you have 0.2396. Okay, so now we are okay with the upper triangular matrix. Sorry. Okay, so we already have the upper triangular matrix here. Okay, so we don't need the operation anymore. Okay, so you can use your calculator to get the final value of x1, x2, and x3. Okay, so I just can put here by calculator. Okay, so you can use your calculator straight away, solve the three simultaneous equations. Okay, the system here is in the form of three simultaneous equations. Okay, and by the calculator, it is 0.9976, x2 is 1.9936, and x3 somehow negative 2.9987. Okay, so that is your final answer for x1, x2, and x3. But basically, the manual calculation comes from, okay, but in the test, in the exam, I hope that you can use your calculator, okay, to speed up your calculation. But the manual calculation is basically here. Okay, so from the third row, okay, in the system here, you can get your x3. Okay, and then after that, you have 0.4119 x2 plus 2.0177 x3 equals negative 5.2294. Since you already have your x3, okay, at this part here, so of course you can get this one as well for the x2. And lastly, you go to the first row to get your x1. Alright, so I hope this is clear. Gauss elimination with partial pivoting. Okay, so remember the keyword is to make sure you check for the pivot element. Okay, so it means that for 3 by 3 system, you need to check 2 times of the pivot. If you have 4 by 4 system, you need to check 3 times whether you need to change the swap rows or not. If the pivot element is already okay, meaning that it is the largest in terms of absolute value, then you do not need to do anything. You do not need to swap rows. So it means that you can proceed with the normal operation. Okay. Common mistake. Okay, at the first stage, normally students are okay with that. Okay, you student okay in the sense that you are aware that you need to check for the pivot. Okay, but along the calculation, sometimes in the stage 2 or even in the stage 3, you tend to forget. Okay, you tend to forget to check for the pivot element. Okay, in most cases, if you have a simple system, your answer are supposed to be the same, regardless you do the pivoting or not. All right. But in terms of marking scheme, if the question asks for partial pivoting, but you do the normal Gauss, then you will be penalized. Okay, because you are not following the instruction. Okay, so I think that's all for the Gauss elimination with partial pivoting. That's all. Thank you. Bye-bye.